Here we go. You just looked right at it.
Yeah.
Hold it down, hold it down.
How's it look in the camera?
It's like a burning star.
Looks like the sun.
I think I went blind.
Okay, that hurt my eyes.
You can't really see it.
Oh, it fell down.
Yeah, same. You could have warned us. Right?
Don't.
You could
All
have
right.
warned us.
So what state of matter is that currently?
That actually.
Right. This is a solid. This is magnesium oxide. Right. It's a white powdery substance. So here we have our copper wire in our silver nitrate, and I want you to just look at the surface of the wire. It was as shiny below the surface of the liquid as above it before, correct? So do you see a reaction happening on the surface of the wire?
Is that just like the reflection from the bottom, or is that?
No, that's, oh, yeah, that's reflection on the bottom.
Oh, okay. That's just not much.
It might look like it's tarnishing, but take a look at the diameter of the wire.
It's expanding, isn't it?
It's growing.
How large is it?
Well, here's the one that I did last hour.
Oh my gosh.
That's gross.
That's gross. What is it?
It's solid. Copper something.
It's aqueous.
Ew. What is it? What are we making? Ew. Sound like a song.
Silver nitrate?
Not silver nitrate. What are the products of this reaction? And silver. You are looking at silver crystals forming. Those are silver crystals. You could. Yeah, there wouldn't be much here. And you wouldn't be getting it for free, because guess what? We have to buy the silver nitrate, and that's where the silver atoms come from. Right? Ready? Here we go. So this is the lead nitrate. This is the potassium iodide. You aren't paying any attention, so you're going to miss this. 1, 2, 3, boom! Oh, what happened there? That's magic. That's witchcraft.
Is that what bananas are doing?
Can I hire you?
I hope not, because there's lead in here, and you don't want to eat lead bananas, okay?
Mr. Franco, can I hire you for a birthday party?
Yeah, that was witchcraft. All right, so here we go. What I'm going to do is I'm going to take the Bunsen burner, and I'm going to heat this guy. And what I want you to notice is that the powder is going to start moving around on its own pretty soon. As the gas is formed inside, it's going to actually, blow the powder around. Because it's fluffy, right? Can you see it yet? I can't see it yet.
It's so fluffy.
Here we go. See it? See it?
Are you going to burn it?
Well, what I'm going to do is I'm going to take a piece of wood. While this is going on, I'm going to take a lit splint.
So it's gonna go out.
It'll either go out or burn brighter.
Gotta burn your fingers.
Ready? Here we go. 1, 2, 3.
It goes. I do
CO2.
CO2. We have two solutions here. This one here, I don't know if you can see it on the background, it's got a blue color compared to this one that's clear. You see the difference? Okay. The blue one here, blue solutions, especially light blue solutions, tell you that there's copper ions present. Copper ions are light bluish. Okay. And this is the sodium hydroxide. So what we're going to do is we're just going to, on the count of 3, 1, 2, 3, we're going to do that. Okay. Now you can see, perhaps, that there's a texture going on there. I think it's easier to see if we try to backlight it. Right? Do you see that the light, that there's a solid present in there? Okay. And that solid is light blue. If I can show you that in a regular light, you'll see it. Okay, so can you see that it's bubbling and fizzing after I put the hydrochloric acid in? Yeah, can we do that? See the fizzing going on in there? All right, so I'm going to add a little bit more so we can really start cooking. And then what we're going to do, because I need to collect this, hydrogen's lighter than air, so if I just let this bubble, all the hydrogen's going into the air. So I'm going to put a little rubber stopper in there, and it's connected to this hose here. And so I've got these film canisters that have holes cut out, and I'm just going to fill them up. Okay, so what's going on in here, right, you can really see it fizzing now, can't you? Right? So it looks to me like the zinc chloride isn't really forming a precipitate, meaning that the zinc chloride, when you are done, is likely to be aqueous, right, because there's water present. It's an ionic compound, and water is present. I've got a few of these. I'll try to fill them all up. Well, that one's got probably holes in it. I doubt that one's going to work real well. We'll try it. Because why not? This is America. We try things. Now, you can't really see the hydrogen coming out, can you? No. Got lids in the bottoms. See what we got here. All right. No way of knowing if this is actually working because hydrogen is colorless and odorless. It's always a roll of the dice. All right, I'm going to move this out of the way. All right, so for the next reaction, is it still recording? Yeah. All right, so I don't know if you can see this thing. This is a little, it looks like a lighter, but all it does is it sparks. See that little tiny spark in there? Okay, so what I'm going to do is I'm just going to place this. Am I on the screen here?
Yeah.
Okay, I'm just going to squeeze the trigger. That one didn't work. Not working. None of them are working. Hey, this is awesome. I'm sure this one doesn't work. All right, we'll try it again. So I'm going to just put a spark on the inside, see what happens.
Oh my